Hello, Mr. Sober here, and today we are going to talk about chemical bonding. This gets a little bit complicated, so I thought it's best to put a video out there just to kind of walk through it. If you weren't in class yesterday, we talked a little bit about bonding, and we did actually do just a quick demo of elephant toothpaste. And if you haven't seen that before, I would recommend going just to YouTube and kind of searching for elephant toothpaste. It's a great example of how something can be very reactive, even if you don't expect it. Because what you actually do with elephant toothpaste is you take hydrogen peroxide, which is very close in its chemical formula to water. So water we know is H2O. Well, hydrogen peroxide is H2O2. So again, it's really close. However, it's really reactive. And again, go ahead, take a look on YouTube at elephant toothpaste, and there's some really cool videos on there. The Mark Rober one is the best, and actually he uses something called Devil's Toothpaste. Same kind of thing, worth checking out. Okay, today what you'll need is just your Chromebook, which obviously you're probably on, and a periodic table. If you don't have one, I'll show you a good one that you can look up online. And first off, I'll have you answer the warm-up question on Schoology. Then I'll just talk you through some basics of bonding. And finally, I'll have you kind of fill in a sheet to really get us ready to dig into what happens when two or more atoms bond. Okay, so first up, we actually have some high-resolution images of a molecule as it breaks and reforms chemical bonds. So they use this cool thing, basically called a light telescope, and it's showing, you can see here, it's kind of blurry because it's really tough to see and you can't really see these very well. But we can see there's kind of more than one thing here, and they're actually breaking up into two things. When you see that, we know that some chemical reaction has occurred. Usually bonds are broken or bonds are made. So that can happen at the same time. Some bonds are broken, some are made at the same time. But the question is, why are some substances explosive while other materials are non-reactive? And if you think back to when we did our adoptive family, we figured out that everything on the very left-hand side of the periodic table is very reactive, whereas everything on the very right, the noble gases, are not reactive. Why is that? Well, it's all about electrons. Valence electrons, remember they're the one on the outermost shell. They have the most influence, and they basically decide whether something's going to bond or not. So basically, chemical bonds are an attempt to fill the outer shell so they're all complete. So let's take a look at how that happens. If you take a look up at the top one here, you can see hydrogen just has one electron, one valence electron. So it's going to want to probably gain one to fill its outer shell. Carbon, nitrogen, and I'll do this. Carbon, nitrogen, and oxygen, they all have two shells, and remember the second shell needs 8 to fill it. Carbon's a funny one. It can either lose 4 or gain 4 to get a full outer shell. If it gains 4 more, it's going to have 8 on the outer shell. If it loses these 4, it's actually going to get rid of its outer shell kind of and remain, or have a full outer shell with 2 electrons. Okay, nitrogen, the easiest way, because it has 1, 2, 3, 4, 5 valence electrons, it's probably going to want to gain 3 electrons to have a full outer shell. Oxygen has 6, so it's easier if it gains 2. I'll move myself out of the way here. The third shell, we're going to say 18 electrons maximum, but don't worry too much about that right now. Okay. So why are some substances explosive? Why do they react? What other materials are non-reactive? Well, it's electrons. The valence electrons. Like I said, an atom may give up some electrons, or it may take some electrons, or it might share them. So those are the three ways it does it. It can give them away, get rid of them. It can take some from another atom, or it can share some with another atom. We'll look at this over the next few days. Okay, if you need to pause this at any point to write this down, you can do so, but I want you to write this down in your notebook, that an atom that gains one or more electrons will end up having a negative charge. Back up. The reason is because electrons are negatively charged. So if you gain something that's negatively charged, you're going to end up having an overall negative charge. All right. The flip side of that is if you lose negatively charged electrons, you're going to end up with a positive charge. Any time an atom gains or loses an electron, we call it an ion. That's just kind of the word we call it to let us know that something's happened there. It's going to be charged now, and the two names we have, if it's positive ion, it's called a cation. The way I remember this is cats have paws, so it's a cation. It's positive. And a negative ion is called an anion. Again, if you need to pause the video to write that down, you can go ahead and do so. Stop laughing. My wife is laughing over the side of my horrible joke. Okay. This is your mission for today, and this is it. We'll move on tomorrow from this. But this is a practice sheet. I will have this as an assignment, but let me go ahead and show you what it's going to look like. Let me get out here. Oh, okay. So what you're going to do is fill in, because we want to know about all of these elements and how many electrons they have, how many valence electrons they have. Remember, this is the most important thing, valence electrons. So let's find out, okay, how many valence electrons do they have, and what are they going to do? Are they going to gain them, or are they going to lose them? Let's do a couple of examples together. And this is where, if you don't have your periodic table, I'm going to just direct you to ptable.com. And this is great because you can just click on whatever element you're looking at and have all this great information about it. It's more than you need, but it's good. All right. Oh, where was I? Okay, here we go. Chlorine's the first one. So let's find chlorine, which is over here. And it's going to ask you a few things. Firstly, it's going to ask you its atomic symbol. That's just its symbol. It's Cl. Total number of electrons. That's always the top number here, 17. That's what we start out with. So 17. Valent electrons. Remember, that's the group number minus 10. So we've got 17 minus 10 is 7. So I went there. There we go. Now, here's what you've got to think. What's easiest to get a full outer shell? Remember, usually it's going to get to 8, except for hydrogen. That'll get to 2 because it's only got 1 inner shell. Okay, so the easiest way to get to 8 is obviously to gain 1. So I'm going to say plus 1. Here is what's called an oxidation number. Oxidation number is just a fancy way of saying what is its charge going to be at the end. So again, if it's gained a negative electron, then its overall charge is going to be negative 1. Okay, let's do another one. Let's do potassium. Potassium's down here. It's number 4. Oh, hold on, I missed something here. Oh, no, that's fine. Okay, potassium number 4. Okay, it's number 19, which means it has 19 electrons. Its symbol is K. 19 electrons. Number of valence electrons. Well, let's take a look. It's in group 1. So it's going to have 1 valence electron. The easiest way for it to get a full outer shell, instead of having to gain 7 electrons, is actually to lose that 1 electron. And if it loses an electron, it's going to have a charge of +1 because it's got rid of a negative charge. What you'll see is that this column is the opposite of this one. All right, let's do hydrogen just because that's the one kind of oddball. So hydrogen is H on the periodic table. It has 1 electron, which means it has 1 valence electron. And again, we can double check that because it's in column 1. Easiest way for it to get a full outer shell. In a shell, it only has 2 on this one, so it just needs 1 more electron to get that full shell. And this is it, hydrogen right here. Again, 2 electrons maximum on the inner shell, so that's going to be full. And again, we can see it's going to be the opposite of this one, so -1. Okay, that's your mission for today. Go ahead, complete this page and submit it. And then we will use that tomorrow to start actually looking at how things bond. If you have any questions, please message me on Schoology.